Welcome everyone. Today we're tackling a critical question for modern Java developers. Which framework reigns supreme for cloud native apps? Well, why does this matter? Today's environment with Kubernetes services and microservices, we need frameworks that have fast initial start times, take less memory, and scale up with little effort. So we want our services to run less like a Ford and more like a Ferrari. But what is cloud computing and why is it important? Well, what we need to understand is cloud native applications represent a modern architectural blueprint designed to build highly available, scalable, and resilient web scale applications in the cloud. So doing this helps us to make new features with faster speeds. In the past, we had monolithic architectures, which had all its functionality tightly into one single code base. This approach made it very difficult to test, deploy, and scale because even minor changes required to rebuild and redeploy the entire system. But today, with cloud-native applications, this problem is solved by breaking down the functionality into smaller, loosely coupled microservices that communicate via APIs. So, for example, in an e-commerce platform, we have a shopping cart. The shopping cart communicates to the payment service and the inventory service, allowing each to scale and fail independently without disrupting the entire systems. And containers are important in this architecture because they help to contain the microservices in lightweight portable units. And unlike traditional virtual machines, these containers share the operating system kernel, which helps to reduce overhead memory in the containers and enable faster startup time. So container orchestrations like platforms like Kubernetes help to further enhance the scalability by automating deployment, scaling, and management, ensuring that the cloud applications can adjust to whatever fluctuations there are and maintain the same high availability. We also see that Java Native Cloud uses DevOps and CI/CD, continuous integration and deployment, which helps to continue making updates as needed and making sure that the services we have on these frameworks is up to what the user needs. And we also see that because of cloud native, now there are open standards that are now widely accepted. So now when applications are built for the cloud, we're not reinventing the wheel. We already have structures and frameworks that we can apply and use so that our time can be spent on innovating new services rather than rebuilding what has already been done. So let's look at the lineup here. We see that we have Spring Boot. Spring Boot is a veteran that is used in many places. It has a vast ecosystem. And we also see Quarkus, which is a newcomer but uses Graal VM native, which helps with its performance greatly. And Micronaut, which is a lean alternative using ahead of time compilation, and it minimizes overhead. So let's see who our contenders are for this, and let's look at their speed and memory and other advantages they have. So Spring Boot is open source Java framework. It's built on Spring and designed to simplify and accelerate Java-based web applications and microservices. It's done through convention over configuration. It's robust, it's scalable, it has very minimal setup, it has widespread community support and extensive documentation. So this is a reliable choice for modern application development. Next, we have Quarkus. This is a full stack Kubernetes native Java framework. Now, it uses Graal VM, which dramatically reduces its startup time and memory usage and makes it an efficient choice and helps to solve Java's limitations in scalability and cloud native architecture. It also uses CDI, context dependency injection. So this helps developers to expand functionality through extensions, which simplify configuring, booting, and integrating third-party tools. So this modular design combined with native compilation capabilities ensures Quarkus delivers flexibility and high performance. We also have Micronaut. Micronaut is a microservice architecture that supports reactive streams for asynchronous data processing with SQL and NoSQL databases. It has message-driven microservices and messaging systems. This framework also simplifies serverless development, offering seamless deployment to AWS, Azure, and Oracle. And it also uses GraalVM, which helps to dramatically increase its performance and memory usage. So let's look at speed comparisons here. So what we see is most notable difference is Quarkus leads ahead in this with its fast startup times. Using GraalVM in native, its capability shines above the others. Micronaut comes in second with about 300 milliseconds. Using its innovative AOT compilations helps to avoid heavy approaches, while Spring Boot comes in a bit slower at around 2 seconds due to runtime introspection. So we see that Quarkus takes the lead here. But now what about memory? Let's see here. So we see memory footprint. Quarkus native compilation dramatically reduces memory usage. Micronaut also maintains lean memory consumption through its compile time dependency injection. And Spring Boot applications typically require significantly more memory through Spring Native. Helps to reduce this over time. But we see here that it still leads a little behind in terms of memory. Now, this is important to take into consideration too, because memory does significantly reduce the resources that one can use for their services. But this is not the only thing to consider. Not just speed and memory, but developer experience is important to consider as well. Because we see that while Spring Boot leads here with familiarity. It has a vast ecosystem, and it helps to resolve any bottlenecks or anything that is difficult to configure. While Quarkus and Micronaut are more newer in the community. They have less documentation and tools to help with setup. So we see that Spring Boot has a very familiar experience and easy to build off of. So now the question here is, which one would you choose? Which one would you choose in these different situations? Let's say you have a legacy integration that you're trying to build a microservice on. Or maybe you're trying to go completely serviceless and change everything up. Or maybe you want a faster startup time with microservices like an e-commerce checkout with webhooks. Which framework would you choose for each situation? I'll give you about 20 seconds to think about this. All right, so what we see here is for legacy integration, what would be best is Spring Boot, because it has more documentation and already has a lot of tools that developers can use to set it up. And we see that, especially if it's using Spring already, Spring Boot would be your choice. But let's say you want to go completely serverless and go straight into Kubernetes, then Quarkus is your solution, especially for a faster startup times and less memory. But let's say you just want fast startup times for microservices like e-commerce or just checkout. Then a good middle ground would be Micronaut framework. What we see here is that not every there's not one tool that fits all. But for a specific problem, there is a specific tool that will help you and your solution. And let's look at a real life example of that with Lufthansa. So Lufthansa had a problem, let's say. It has a powerful tool to use for its digital platform, Avatar, which helps to track and maintain international aircraft. So it wanted to have a more, it wanted to have a faster and leaner framework to help support its services so that it could be more accurate and it could help relieve some of the bottlenecking in services. So it switched from Spring Boot to Quarkus, and by doing so, it dropped its resource usage dramatically from 1.5 cores and 3 gigabyte RAM per instant to just 200 millicores and 200 to 400 megabyte RAM. So this, while running the operations 3 times faster, this efficiency helped Lufthansa Technik to build a more responsive platform for optimizing airline operations. In conclusion, what we see is that there is no single best framework. There's only the right fit for your specific needs. GraalVM adoption is growing and its performance is getting better, but it still doesn't have the same resources like Spring Boot. But over time, that line can blur. So for ourselves, let's be familiar with both tools. One thing is clear. Java isn't going anywhere. Its ecosystem is evolving and is heading towards lightweight cloud-first solutions optimized for microservices. And I hope that we understood just a little bit more about Java native cloud frameworks and their importance today.